Okay, so what we've been talking about so far is that we've only been dealing with one gas at a time. So we've assumed that if we've got a gas, we've only one gas at a time. So now, what most of the time we're dealing with mixtures of gases. So, and some other times we're also interested in the pressure of a component gas that's in a mixture. So what we have to do is use something called the Dalton's law of partial pressures. Dalton's law of partial pressures. Okay, so what Dalton's law of partial pressures says is this, that the total pressure of the system, okay, is going to be equal to the sum of all the individual components. So let's say you have a mixture of three gases, then the total pressure of the system is going to be equal to the pressure of gas A plus the pressure of gas B plus the pressure of gas C. Now, if we were to take the pressure of component A, okay, so if I take gas A and divide it, the pressure of gas A divided by the total pressure, we actually get something called the mole fraction, which we represent with the Greek symbol chi. Okay. So this is the mole fraction, and by definition, the mole fraction is going to be the number of moles of A, of whatever A is, divided by the total number of moles of the system. Now, because we're dealing with fractions, the mole fraction is going to be unitless because the moles divided by moles is going to give you nothing, but the number should always be less than 1. Okay. Finally, how are partial pressures determined? Well, if you know the mole fractions of the components, then you multiply by the total pressure of the system. So if you wanted to solve for the pressure of component A, if you take the total pressure and then multiply it by the mole fraction of A, you can actually get that individual component pressure.